So the first thing we're going to do is we're going to take the blank sheet of paper. Some of y'all probably have something on the back of it, but I want everyone to pick up the sheet of paper. We're going to take this sheet of paper and we're going to fold it in half, but we're going to record the number of sections we have after each fold. We have a paper that's being stapled, and then the other sheet of paper that you picked up. It's the same thing. This is scratch paper. Yes. So the first time we're going to do it, how many sections do we have after no folds? How many sections? One. So when I don't fold my paper at all, I have one big section. Yes, that's the paper. From here, I'm going to fold it one time. It doesn't matter if you fold it this way or this way. I don't care. Just fold it in half. After you fold it in half, open it back up. How many sections do we have? Two.
Are they kindergarten?
Yes. Alright, then we're going to fold it in half again.
So if I have it this way, do I hold it this way or this way?
However you want to fold it. And I open it up. How many do I have? So you can count the number of sections. So if I fold it in half again, how many do I have? Nope, not 6.
8.
Why is it 8?
8.
It's 8. So if I fold it in half again, to this, then fold it in half again. Yeah. So after I fold my piece of paper 4 times, how many sections do I have? 16. Y'all finish the chart. Y'all finish the chart. It depends on how many times you folded it.
I just folded it. It was like this. I had 8. I did it again.
So that would be 16. And if you fold it again, how many do you think it will be? Not 24.
How many?
Mm-hmm. Count them. And you need to be writing.
Oh. See, this is all types of messed up.
The 20th.
You look springy. I got 32.
Mm-hmm. So after I fold my piece of paper 5 times, I should have 32 sections. If I fold it 6 times, how many do I get?
6.
Do y'all notice a pattern here?
It's going like 8, no 4.
Every time I fold my section, I'm going to multiply the number of sections I had previously by 2 to get the next one. You can unfold your paper. We're done with the paper now. That's all we're going to use it for. Alright. What value did I start at? How many sections did I have at the very, very beginning? 1. So I had 1 section. Are the number of sections increasing or decreasing every time I fold it? Increasing. The last question is, what pattern did you notice by the number of sections? Every time I folded it, what happened? Multiplied by 2. So that time we counted the number of sections. This time, we're going to look at the area of each section. So if I had my paper, you don't have to fold it or anything, we're just going to look at it. If this was unfolded, I had never folded this piece of paper before, the total area for this paper, we're going to put as 1. But I take my paper and I fold it 1 time. Compared to the area I started off with, to folding it in half, how much of the area do I have left? Not 2. What? Half. Compared to the whole area I had to begin with, if I fold my paper in half, I have half of the area left. So if I fold it again in half, I have 1/4. What if I fold it again? How much area do I have? Not 1/4. 1/8. Good job. What if I fold it again? So this time the area of the paper got small, of each section got smaller as we folded. So what was the value that I started at? 1. Now, was the area increasing or decreasing? Decreasing. As we folded, what happened or what pattern did y'all notice about the area as it got smaller? We didn't subtract 1/2. Or something happened with the 1/2. Okay, we can either say it one of 2 ways. Multiply by 1/2, or we could have said that they divided by 2. It's the same thing. So each time we cut in half, so each time it got cut in half or it was divided by 2. So if we look on the next page, this was an example of an exponential function or an exponential equation. The model of an exponential equation is y equals a of b times x, or to the x power. Can anyone tell me what do y'all think a is going to represent? Not 1. Did you read ahead? Y-intercept. A represents the y-intercept. B represents the common ray. The reason why A is our y-intercept is because if I have a y-intercept, what is the x value of a y-intercept? If I have an ordered pair and I tell you that this ordered pair is a y-intercept, what does x have to be? Zero. So if I plug in 0 for x, anything to the 0 power is what? 1. So that means that this, if x is 0, is going to be my y-intercept. So let's look at an example. It says, a bacteria can multiply at an alarming rate when each bacteria splits into 2 new cells, this doubling. Part A wants us to write an equation that represents this situation. The first thing I have to know is, what is my y-intercept? When I say y-intercept, I'm looking for a specific number. Two.
What?
Our order pair for our y-intercept is 0, 2. But our initial start point is where 0 is, but it's the y value, which is 2. So I'm going to have 2 parentheses. Now I'll have to figure out what b is. To find out what b is, I take any term I want to. So for this instance, I'm going to take 4. And I'm going to divide 4 by the previous term, or the term that happened or occurred before it. So I'm going to divide 4 by 2, which gives me 2. So that means my b is 2. And that will be my answer. I could have picked any of these points I wanted to, or these terms. I could pick any one I wanted to and just divided it by the previous term. It would always give me the same answer. Now, part B asks us, after how many hours will there be over 1 million bacteria? If this is my x, and this is my y, it asks how many will there be over 1 million bacteria. Where are we going to put 1 million? In for x or in for y? We're going to put 1 million in for y. We have not learned how to solve for x yet. So if we're given a problem like this, we're going to have to play the guessing game. We're going to have to pick numbers that we think we can put in for x to get as close to that number as possible. We might not find the exact answer because we don't know how to do that yet, but we're going to play the guessing game. So right now it says 13 hours, we have 16,000, a little over 16,000. But 24 hours gives us over 3 million. So we know that in order to get 100 million, or 1 million, we have to find a number that's between 13 and 24. What number do y'all want to try? 18. Okay, put 18 in the calculator for x. Put 18 in for x. We're not using those anymore. Because. You just gotta use it. I mean, I can't tell you if you don't have a calculator.
What the heck?
You're going to type 2, parenthesis,
Hold on now.
2, close your parenthesis, do the caret button or the house button.
Okay.
Nope, left.
This right here.
Or go right.
The little,
Right,
the little
right, right,
there.
up. Yes. And then type in 18. Click enter. What do you get?
55,242,080. If I spell it right.
I think that's 52,000.
It's not 23.
Not 23, 23.
Mm-mm.
No, it's not 52,000.
There's a number before that will get you to a million. Mhm.
I have to type it in right. Didn't I? Yeah.
Mhm. Okay, that means 18. No, you typed it in right. Is that number a million yet?
Never mind, 1,000.
You gotta keep going up.
Okay, so how many numbers are there? Okay,
So try the next number.
so 3.
So you're going to type in everything the same way except saying 18. You're going to put in 19.
So 3, 3, 9.
Nope, not 3. It's going to be 2. Parentheses 2 parentheses caret 19. Does that give you? Okay. So there's still a number before 21.
Can I set a
The
number?
first number that will put you over a million. You have to find out what that number is. Mitiana just found it.
What is it?
104,850,000.
Yeah, but there's a number before that that will put you over a million. You have to find the number, the very first number that will put you over that limit.
It's 19.
Do these things solve?
Try 19.
You didn't explain us very well. In that charging station. Would you plug it in?
Yeah, I was just like, where's the little charger controller?
Mhm.
Oh, I was.
Does that make sense?
How can you do this? And I write down here.
So it will take us 19 hours to have over a million bacteria. This is just the guessing game. Because we don't know how to solve for x yet. That's something that y'all are going to learn how to do in Algebra 2. Alright, so let's look at the next example.
Can we clear this?
You can clear it. It says, given the following table, write the equation that represents the information below in the chart. First thing I have to know, what is my y-intercept? What's my y-intercept? 81. So my y-intercept is 81. Now, how do I find b? Please get up and put that in the trash. Thank you.
Oh, let's put another 81 in front. Are we going to something we did?
Mhm.
81 if you do it.
How do I find b?
Right there.
Mhm. We're not dividing by 2 though.
You have to follow.
Pick.
Take a number like 9 and divide it by 3.
Is that okay? We're going to take 9. But when I divide, I have to divide by the previous term.
Oh, 27. Oh, I thought we were going to
Oh.
It's the previous term. The term that occurred before it. So what is 9 divided by 27?
3.
Nope.
Wait. I'm crazy. 0.
Okay. But what is that in fraction?
1/3.
1/3.
Let's just put all those.
So 1/3 is b.
Why does it put all those 3s after 3? Why can't it be like 0.3?
Because it's a repeating 3. Yes, it never stops. So this is my equation for problem 2. When our numbers are decreasing, because if we look at our chart, we start off at 729 and we end up with 3. So as our numbers are decreasing, that means that our b is going to be a fraction. If they're increasing, Our b is going to be a whole number. So let's look at problem number 3. It says, each year the local country club sponsors a tennis tournament. The play starts with 128 participants, and during each round, half of the players are eliminated. Write an equation for this scenario. First thing I have to know of, the y-intercept. How many people do I start with? 128.
Wait, no. It says it. Oh, okay.
I was about to say 61.
Now, how do I find b?
You have to take 32
No, 16 and divided by 32.
Okay, we can do 16 divided by 32. What's 16 divided by 32?
0.5.
Which is 1/2. So my equation is y equals 128 times 1/2 to the x power. Part B asks us to find how many players are left after 6 rounds. We're going to plug in 6 for x. So in your calculator, you're going to have 128 times 1/2 to the 6th power. Two. So when you plug in this problem into the calculator, you should have gotten 2.
How do you put it in 1/2?
You're going to do 128 parentheses 1 divided by 2. Close your parentheses. And then to the 6th power. 2. Problem number 4. A colony of insects triples every day. If the colony has 80 insects today, how many will be present in 10 days? So how many did I start off with? If it triples every day, B is going to be our 3, because that's our common rate. So every day it triples. Instead of writing x as my exponent, I'm going to write 10, because it wants to know after how many days, or 10 days. So what is y?
472,000.
Keep going. Just say the numbers.
47239.
Did you plug it into the calculator? So put 8, 0, parentheses, 3, caret, yep, 10, enter. Oh, you didn't do 0, yep, enter. Alright, I want y'all to try the last page on your own. Try this one on your own. Off.